Hi everyone, let's continue to talk about Richardson's extrapolation. The technique Richardson's extrapolation provides a method of improving the accuracy of a lower order approximation formula, H, whose error can be expressed as the following. So here A is the true value, and then A of H is approximation. Then the right hand side are the error. Okay, and you can see the errors are even powers of H. Okay, and those coefficients of the error terms A2, A4, they don't depend on the step size H. For example, do you remember our to approximate the first derivative, we have 2 point forward formula and 2 points backward formula and a 2 point central formula. And the 2 point forward and the 2 point backward formula, they are all first order error. But our central difference formula, okay, is second order error. So in that case, A is the true value, AH is the formula, the central difference formula, and then the error is the second order error. Okay, that is the example. Then how do we get a fourth order error approximation to A? By the way, remember if the degree of the H term is higher, the error is actually smaller because the step size is usually very small. And think about 0.1 squared is 0.01, but 0.1 to the fourth is 0.0001. So higher the higher the degree, then the smaller the error. Okay. So to start the process, we form approximations to A using steps H and H over 2. Let A1 and A2 be the approximation respectively. Okay, so let A1 be the approximation using step size H. Then we can just plug into the formula, this formula, and then we get this guy, right? These are the errors. And then when we use step size H2, let A2 be the approximation. Then the formula becomes, so this is A2. We replace H by H over 2. You can see these are H over 2. But now let's split the powers. Then we have 1 over 4, A2 H squared, and 1 over 16. And here's 1 over 64 because 2 to the 6 is 64. So far, so good, everybody? Okay. Then let's our goal is to get rid of the H2, the H squared terms. And how can we do it? We multiply the second equation by 4. Then we get 4a equals 4a2 plus a2 H squared plus 1/4 a4 x to the 4th, and etc. Okay, now we can subtract the first equation from the third one. Then we can get on the left hand side, we have 4a minus a equals 3a. On the right hand side, we get 4a2 minus a1. And then the next term, this guy, a2 h squared, they cancel. Okay, and then the next term, we have 1/4 a4 h to the 4th minus a4 h to the 4th. That is minus 3/4 a4 h to the 4th. And the next one, we have 1 over 16 minus 1. That is negative 15 over 16. Okay, now we can solve for a because we can divide both sides by a. Then this is our new approximation. Okay, so this is our new approximation. Now these are the error. Now you can see the error is a fourth order error, right? This is degree 4. So now we get given the formula of second order error, we can use step size H and H over 2, and then use this formula. It will give us a fourth order error approximation to the A. Okay, and how do we get a sixth order error approximation to A? Okay, this is also called the second level extrapolate approximation. Okay, so suppose we form approximation to A using step size h, h over 2, and h over 4. Now we let A1, A2, and A3 be the approximations respectively. Okay, then we can use the above stage to find the fourth order approximation. So let B1 be 4A2 minus A1 divided by 3. This is the same thing as before. Okay, but we call it B1. And then B2, so B1 we use A1 and A2 and get the B1. B2 we use A2 and A3 to get the formula. So far so good, everybody? Okay, and then what is next? By the similar algebra calculation, okay, we can like match the h to the fourth term and we want to cancel it. And at the end, you will see the new approximation is 16b2 minus b1 over 15. Okay, and then the error is a sixth order error. Okay. Now, the linear combinations of, well, here we have 3 because we need A1, A2, A3. 3 applications of the second order approximation using step size h, h over 2, and h over 4. This will give us a sixth order approximation to A. So this is the Richardson extrapolation method. Okay, so if first stage, if we only use step size h and h over 2, we will get the fourth order approximation. Second stage, if we use the approximation of step size h, h over 2, and h over 4, and by those 3 formulas, so 1, 2, 3, 3 formula, we can get a sixth order approximation. Alright, so let's do some example. So example 4. The following approximation of f prime of 2 were obtained from a different second order approximation. Okay, so we have the step size h is 0.01. Okay, so this is the step size. H is 0.01 and we also have h over 2. See, h over 2 is like 0.005. Okay, then what does that mean? H corresponds to the approximation A1. H over 2 corresponds to the approximation A2. Okay, then the extrapolation method tells us that the A is approximately equals 4 times A2 minus A1 over 3. You might ask, do I need to memorize this formula? You don't. So I will provide a formula sheet to you like in the exams. You can also look at the practice exams, then you can see what formula I'm going to provide you in the midterm exams. Okay? So let's plug in 4 times, this is 2.4031 minus 2.3727 over 3. And let's see what this number is. Calculator, where are you? Oops. Let me see. Okay, this is our calculator. Where? Let's see. Okay. 4 times 2.4031. And then minus 2.3727. Okay, and that answer divided by 3. 2.4132, 3 repeated. 2.4132, and then we have 3 repeated. Okay, so far so good, everybody. All right, let's continue. Okay, so example 5. The following approximation of f prime of 4 were obtained from a different second order approximation. Okay, so here you can consider this is h over 2, this is h over 4, right? If h is 0.01, then h over 2 is 0.05, then h over 4 is 0.0025. And then the approximation corresponds to A1, A2, and A3. Then we're going to use the formula. What is the formula? Those three formula. B1 equals 4A2 minus A1 over 3. B2 is 4A3 minus A2 over 3. And A is 16B2 minus B1 over 15. Okay, keep those in mind. Let's calculate here. So B1 is 4A2 minus A1 over 3. A2 is negative 1.2589 minus A1. So minus negative become positive. 1.2345 all over 3. And what is that? Okay, where is our calculator? Right here. So let's see. Here we have 4 times parentheses negative 1.2589 and parentheses plus 1.2345. That answer divided by 3. So we get negative 1.26703 repeated. So negative 1.26703 repeated, right? And then B2 equals 4A3 minus A2 over 3. So A3 is minus 1.2937 minus negative become positive 1.2589 over 3. And let's see. Okay, let's plug in our calculator. So here we got let's see here. Okay, we get 4. Let's do minus 4 times 1.2937, and then plus 1.2589 and all over 3. Okay, minus 1.3053. Okay, finally, our approximation equals 16B2 minus B1 over 15. Actually, how do I memorize this formula? Think about it. 4 minus 1 is 3, right? 4 minus 1 is 3, and 16 minus 1 is 15. This is how I memorize it. And you always put the approximation with a smaller step size in front and use it to subtract the approximation with a bigger step size. Okay? So this is how I memorize it. Okay, so that equals 16B2. B2 is negative 1.3053. And then minus negative become plus 1.26703 repeated all over 15. Let's see, here we have parentheses, and then we have this number times 16. Oops. And then minus, we can do plus this number. and all over 3. Oh, sorry. It's not over 3, over 15. Okay. Because all those answers should be close to each other. Because they're all approximations, right? So our answer is minus 1.30785. So minus 1.30785. So far, so good, everybody? Okay, so that is the Richardson extrapolation method. Let's continue to do more examples. Okay, so example 6. The position of an object was recorded. So we have the t seconds and the meters. Use appropriate fourth order method to approximate velocity and acceleration of the objects at t equals to 2 seconds. First, let's look at velocity. Okay, t equals to 2 seconds. So we want to find the velocity and acceleration at t equals to 2 seconds, right? And here we have 5 data points. Okay, so we can use the central difference formula. By the way, if you want to use the Richardson extrapolation method, you must start with a central difference formula because that will give you the second order error approximation. Okay, you cannot use the 2 point forward or 2 point backwards formula because that is only first order error approximations. Okay, what is the central difference formula? Well, that is f prime of xi equals f of xi plus 1 minus f of xi minus 1 and then over 2h. H is the step size. So far, so good, everybody? Okay. Here, what is the step size? Well, this is the step size? No. Think about it. If we use Richardson extrapolation method, we want to find the approximation corresponds to h, and the approximation corresponds to h over 2, right? So, and then in this case, we'll say the smaller point is going to be the step size h over 2. So h is actually from 1.2 to 2, that is 0.8. Then h over 2 is, what's the difference between 1.6 and 2? 0.4. So far, so good, everybody? Okay, now our V1 approximation, V1 using step size h, which is 0.8. That is f of 2 plus 0.8 is 2.8. So we're using these points, these 2 points. Okay, the first point and the fifth point. So f of 2.8 minus f of 1.2 over 2.8 minus 1.2. This is actually 2 times 0.8. So f of 2.8 is 77, and f of 1.2 is 23 over 1.6. Okay, so let's see. Calculator, where are you? Here, 77 minus 23, and then divided by 1.6. 33.75. So this is the first approximation. For the second approximation, we use step size h over 2, which is 0.4. So we use the second point and the fourth point. So f of 2.4 minus f of 1.6 over 2 times h is 0.4. So in this case, f of 2.4 is 59, f of 1.6 is 34, and the bottom is 0.8. So let's see, here we get 59 minus 34, and then close it, divided by 0.8, 31.25. Okay, so we get the first approximation and the second approximation. Then we can use the Richardson's extrapolation method to get the fourth order approximation. So V is then, remember, 4 minus 1 equals 3, right? Before we used the later approximation V2, and here we use the bigger step size approximation. So we have 4 times 31.25 minus 33.75 all over 3. Okay, let's see what it is. So we have 4 times 31.25 minus 33.75. And oops, I missed a 7. Okay, divided by 3. 30.416. Repeat it. So far, so good, everybody? Okay, so that is the approximation of velocity. Now, how do we find acceleration? Well, what is acceleration? Acceleration is the second derivative of the displacement, right? So second derivative, well, we need to look back for our formula. Our formula, okay, we talk about the central difference formula, and I provide you a formula for this. See, this is the, oops, too much here. Okay, all these are the central difference formula. We have the first derivative, second derivative, third derivative, and the fourth derivative. So here we're using the second derivative. Okay, so keep that in mind. Let's go back. Okay, so here we have f of xi plus 1 minus 2 f of xi plus f of the x sub I minus 1 over h squared. Okay, so what is A1? A1 is the approximation using the bigger step size. And here for the second derivative, we need 3 points. So which are the 3 points we use? This guy, and this guy. There's 3 points. Okay, so f of xi plus 1 is f of 2.8. And minus 2 f of xi is 2. Plus f of x sub I minus 1 is 1.2. And then all over h is 0.8 squared. Okay, if you can remember, f of 2.8 is 77. F of 2, what is f of 2? Okay, 46, and then the other one is 23. So this is 46, and then this is 23.8 squared. Okay, let's plug this in our calculator. 77 minus 2 times 46. Oops. 46 plus 23, and then divided by 0.8 squared. Okay, 12.5 is our answer. Alright, so for A2, which 3 points are we going to use? Okay, we're going to use the step size h over 2, which is 0.4. Then we're going to use these 3 points. So 1.6, 2, and 2.4. And displacements are 34, 46, and 59. Okay, keep that in mind. So this is f of 2.4 minus 2f of 2. And then here we have 1.6 all over step size is 0.4 squared. Okay, 2.4 is 59. And then f of 2 is 46. And then f of 1.6 is 34. Okay, by the way, you can always like pause the video and then to think through it. Okay, and please, before you start each example, try it first and then you can continue to play the video to check your answers. Right? Okay, calculator. So 59 minus 2 times 46 plus 34 and divided by 0.4 squared. That is 6.25. Okay, what is our A? 4A2 minus A1 over 3, right? A2 is 6.25. A1 is 12.5. What is the answer? Okay. Let's see. So we have 4 times 6.25 and then minus 12.5 and divided by 3. Okay, so the answer is 4.1 and 6 repeated. So far so good, everybody? All right. So this is the Richardson extrapolation method. But like this example and the previous example, I show you how to use the Richardson extrapolation method. But you might ask, does it really work? We get a number, we get the approximation, but how close is this approximation? Well, we cannot see it from these two examples, but we can see it from the below examples. Do you remember that? Example 2, we use the forward difference formula, okay, to get the approximations, right? And I asked you to when you get back home, after class, you can try to redo the problem using central difference formula or the backward difference formula. Okay, so actually now let's do it again using the central difference formula because that is the second order approximation. After we get the approximations, we can use the Richardson extrapolation to approximate it. And here, because we have 3 data, we will actually get a 6th order approximation from this data. Okay, and here we know this is the true value. So let's use the Richardson extrapolation and get the 6th order error approximation. Then we will see, we'll be able to see how close to the true value. Okay, good. All right, so this is H, right? The biggest step size is H, and then half of it's H over 2, and then a quarter H over 4. So far, so good, everybody? Okay, so what is the central difference formula again? F prime of xi equals fi plus 1 minus fxi minus 1 over 2h. Alright, so keep that in mind. When h equals 0.1, we call this guy A1. A1 is f of, we're looking at the point 1, right? So this is 1 plus the step size, so it's 1.1 minus f of 1 minus 0.1 is 0.9 over 2 times 0.1. So far, so good, everybody? Okay, what is this guy? Well, we get e to the 1.1 square root 1.1 square plus 3 times 1.1. And then minus, we plug in 0.9, so e to the 0.9 square root of 0.9 square plus 3 times 0.9 all over 2 times 0.1. So far so good, everybody? Okay, now let's plug this in our calculator. Okay, so calculator, where are you? Here. So, oops. Okay. I need, okay, then I can see it. So we have parentheses e to the 1.1 and then square root of 1.1 square plus 3 times 1.1. Okay, let's type everything here. And then this is e to the 0.9 and then times square root of 0.9 square plus 3 times 0.9. Okay, all of that divided by 2 times 0.1. You might ask, why don't I just put 0.2 there? Because I want to keep this whole formula, but then next time when I calculated A2 and A3, I could just change some number there. I can use the same formula, but change some number there. Okay, it will make it easier for the future. So we get 8.859052554. So 8.8590. And what is that? 5254. So this is A1. You can see it's still close because the true value is 8.83 something. So we get 8.85 something, but still close, right? It's not a way off of it. Okay, let's see when h equals 0.0. Let's do h over 2 is 0.05. And then we have A2. A2 is f of 1.05 minus f of 1 minus 0.05 is 0.95. And we get 2 times 0.05. Okay, what we gonna change? Replace 1.1 by 1.05. Replace 0.9 by 0.95. See, it's very similar to the above equation. Replace 0.1 by 0.05. Alright, what is that number? Okay, so our calculator. So calculator, where are you? Here. So let's copy this and replace 1.1 by 1.05. And 0.9 by 0.95. And 0.1 by 0.05. Okay, 8.84057, 8.84057, and then 1366, 1366. See, it's closer to our true value. Okay, when the step size h over 4, which is 0.025, well, out we get A3. A3 is f of 1.025 minus f of 1 minus 0.025 is 0.975 over 2 times 0.025. Okay, so the formula very similar to the previous steps. Just replace 1.05 by 1.025. And you might ask, can I like not write all of these again? Well, the thing is, please write down the steps because if you make mistakes, you can get most of the points. You can get the partial credits. Imagine if you don't write down the steps. If you have a wrong number, then to me it's just a wrong number. I don't know how you solve the problem. I don't know how you get this number. So I cannot give you any partial credits, right? It's just a wrong number to me. Then you get 0 points for this problem. So please write down these formula steps. At least let me know like how you think. Now, even though you make a mistake at the end when you plug into the calculator, you will get most of the points. Okay, so here we copy the previous steps. You can also use your calculator to go up to the previous line and then enter, and then you can have it. Okay, you don't need to type everything again. So this is 7, 7, 7. This is 2. Okay, so 8.83595. And then what is the next? 4566. Okay, you see our answer is getting closer. So what we have done, all of these are the central difference formula, and then they are second order error. Okay, and then next let's find the B. Okay, so what is B1? 4a2 minus a1 over 3. B2 is 4a3 minus a2 over 3. Okay, let's calculate. For a2 is 8.840571366. A1 is 8.859055254. And then all over 3. Okay, calculator. So parentheses 4 times, okay, which number? 8.84. So this number we copy down here, and then minus, go up, copy this number here, divided by 3. Okay, 8.83441. And then what's next? 0975. Okay, B2 is 4 times A3. A3 is 8.835954566. Minus A2. A2 is 8.840571366. All over 3. Okay, now let's see. So we have 4 times 8.830. Okay, this number. Oh, I forgot times here. Okay. And then minus the previous number, 8.84. This number, copy down, divided by 3. Okay, 8. Oh, you see the answer are already very close. 8.83441. And then the last 4 digits is 5633. See, they're already very close to each other, and then they're already very close to the true value. See, the true value is right here. Okay, so finally, our 6th order approximation is 16 minus 1 equals 15, right? So B2 here, B1 here. B2, 8.834415633 minus B1, 8.834410975, all over 15. Okay, let's see what this number is. 16 times, okay, copy again. Which one? This one. and minus this guy. So you just go back up using your calculator and enter. You can get those numbers. Divided by 15. Okay, 8.83441. 8.83441 and 5944. Let's look at our true value. Oh, see? Almost the same, just the last digit difference. Our last digit is like 3944. The last digit is 4. But our true value, the last digit is 2. But it's already very, very close because this is the 6th order error approximations. So it's already very accurate. So far, so good, everybody? Yes. So keep in mind, right now the formula we use, the second order error approximation are the central difference formula. Okay. So in order to use the Richardson extrapolation method, you have to start with a second order error approximations. Okay. And then we can apply the formula of the Richardson extrapolation. Then we can improve the approximation to the 4th order error or the 6th order error. So far, so good, everybody? Yeah, I hope this last example can show you, wow, this method is really cool. It can help us to approximate our answer to, wow, a lot of digits. Okay, and that's it for today. Have a nice day. When you have questions, don't forget to ask me. Bye.